In section 8.3, we're actually going to talk about now how to actually do some hypothesis testing. And we're going to test a claim about a proportion. So we want to remember that the p-value of a sample is the probability that this sample occurs based on the assumption that our null hypothesis is true. So we always assume it's true, and we get a probability value, and that then determines whether we reject our statement or we don't reject it. So our first claim says less than 20% of all workers find their jobs from newspaper ads. Okay, so first we need to write our null and our alternate hypothesis. So remember, since this is a less than statement, that's going to be our alternate. This is a proportion, so we're going to say P is less than 0.2. Now, our null always has an equal, so our null will be P equals 0.2. And our original claim has the less than, so our original claim is H1, the null hypothesis. Now, at the very end, when we make our conclusion with the null hypothesis, the alternate hypothesis, there are only two things we can do. We either support it or we do not support it. Okay, so if our sample has a low probability of occurring, we get a really small p-value, we'll reject H0, which means we'll support H1. Okay, if we get a big p-value, then we will not reject H0, and we will not support H1. Okay, so here's our data. It says to test this claim, we survey a simple random sample of 700 workers, and 16% of this sample found their jobs from newspaper ads. Okay, so we want to know, does our research support the claim? Is a sample of 16% likely to occur? Okay, so another way of stating this is if 20% of all workers really do find their jobs from newspaper ads, if that's true, then would it be unusual to get a sample where only 16% found their jobs? So to do hypothesis testing, we always have to pick a significance value, and right now we're just going to go kind of in the middle. We're going to let alpha be 5%. Okay, so now we're going to use our calculator to find a z-value and a p-value. Now, the z-value, we don't really use it to make our decision, but my math lab might ask you for it. So the following key sequence tells us how we get the stuff. So you're going to hit the stat button on your calculator, and then you're going to use the right arrow to arrow over to where it says test at the top, and you're going to choose number 5, 1 prop z-test. Okay, and you're going to enter the following information into your calculator. Now p null, that's going to be what you used in your null and your alternate hypothesis. So that's going to be 0.2. Now our x is actually how many people found their jobs from our sample. Now, we weren't given that information, but we can find our x. We were given that we had 700 workers and 16% found their jobs. So we're going to take 16% of 700, which is 112. So for x, we're going to put 112. And our n was 700. Okay, now our claim was that the proportion was less. Remember, our claim was that p was less than 0.2. So this p0 is our 0.2. So we're saying it's less, the p is less than 0.2. So now you're going to choose calculate, and it will come up with your z-value, which it says is negative 2.65, and a p-value, 0.0041. Okay, so now, remember alpha was 0.05, so our p-value here is less than alpha. And if you look back at section 8.2, what that means, if p is less than alpha, we reject the null hypothesis. Okay, now the original claim was the alternate hypothesis. When we reject the null hypothesis, we support the alternate hypothesis. So our final conclusion would be the sample data supports the claim that less than 20% of all workers find their jobs from newspaper ads. Okay, our next one is a hypothesis. It says 50% of all adults rarely or never fly on airplanes. So this is actually an equality statement. So P, we're saying, is 50% or 0.5. Now, when our claim is the null hypothesis, our alternate is always P does not equal whatever number. So P does not equal 0.5. So our original claim this time is the null hypothesis, is H0. So with H0, we can either reject it or we do not reject it. Those are the only two words we can say. Okay, so our sample proportion will either be greater than 50% or less than 50%. So it says to test this claim, we survey a simple random sample of 1,126 U.S. adults, and 597 of them say that they rarely or never fly. Okay, so if we want to find the percentage, 596 of 1,126, which you would just take 597 divided by 1126, we get that this is 53%. Okay, so we want to know, is this likely to occur if the real percentage is 50%? So we're going to let alpha here be 0.10. So we're going to, again, you're going to go to stat, over to tests, and choose one prop z test. For P0, we put in our 0.5. For X, that's how many people said they rarely or never fly, so that's 597. And for N, that's our total sample size, 1126. Okay, and then remember our alternate claim was that P does not equal 0.5, so we choose this first one. Okay, and then hit calculate. And the calculator will give us our z-score. Here it's 2.03, and our p-value, 0.0427. Now remember our alpha was 0.10, so again, p is less than alpha. And since p is less than alpha, we reject the null hypothesis. So we'd say we have rejected the hypothesis, which was also our claim. So we'd say there's sufficient evidence to reject the claim that 50% of all U.S. adults rarely or never fly on airplanes. Okay, and the third one we're going to do, the claim is that cell phones cause cancer. So it says people who use cell phones have a significantly higher chance of developing cancer in the brain or nervous system compared to non-cell phone users. Okay, so they also have to tell us that about 0.034% or 0.00034 of non-cell phone users develop cancer. Okay, so if our claim is that cell phone users have it more, we would say for cell phone users the proportion is greater than 0.00034, which would make our null hypothesis P is equal to 0.00034. Okay, now since our claim is our alternate hypothesis, H1, remember we either support H1 or do not support H1. Okay, so if we have a low p-value, then we'll reject H0, which would mean support H1. If we do not reject H0, we do not support H1. Okay, so it says to test this claim, we study a simple random sample of 300,000 cell phone users. We find that 108 of them do develop cancer of the brain or nervous system. Okay, so 108 out of 300,000 is 0.036%, so that's what we're testing. Okay, now, since this is a pretty important topic, we're going to let alpha be 0.01. So our P is 0, that's what we put in our null and our alternate. In our calculator, we're going to put 0.00034. From our sample, the numbers who did develop cancer was 108, and our N was 300,000. Okay, and remember, our original claim was that our proportion was bigger than P0, so we're going to use the greater than symbol, and we choose calculate. So the z-value gives us is 0.59, and the p-value it gives us is 0.2762. So remember our alpha was 0.01, So obviously P here is much bigger than that. So since P is bigger than alpha, we do not reject the null hypothesis. And since we don't reject the null hypothesis, we cannot support our alternate hypothesis. So formally, we have not rejected the null hypothesis. So our statement would be, we do not support, or you could say our evidence does not support, but we do not support the claim that cell phones cause cancer of the brain and nervous system.